follow along on your note sheet. When you finish these notes, check them with Mrs. Lehman and then put them on page 33 in your notebook. So transition metals use Roman numerals, and these are Roman numerals. That first one is 1, 2, 3, 4, 5, and so on. The valence number of a transition metal may vary. The valence number, so that means the number of electrons that a transition metal might lose when it becomes an ion can change. As a result, a single transition metal may have more than one charge, and we call this multivalent. Multivalent. And this is indicated through the use of Roman numerals. Transition metals still lose electrons, and the same naming rule applies. The name of the metal goes first. The oxidation number is the same thing as a charge, will determine what Roman numeral, 1, 2, 3, 4, or 5, you will use. For example, iron has two oxidation states, Fe2 plus or Fe3 plus. So here we have Fe2 plus. It has a charge of 2 plus. So whatever Roman numeral that we use needs to match that charge. So we're going to use the Roman numeral for 2, which is 2 lines, and so its name will be iron 2. And the same goes for iron 3 plus. It has a charge of 3 plus, so that's going to be the Roman numeral that we use. So that's the Roman numeral for 3, and it'll be iron 3. Remember, the non-metal name slightly changes by adding "ide" to the root of the name. So that was like the chloride, fluoride, and so on. So when does this apply? Well, it applies when we have multivalent elements, which are most of our transition elements. So whenever there's an element in this box all the way over to here, in this box, not including gallium or aluminum, but everything else to the right side of the transition elements, these are all multivalent electrons. So whenever we use any of these, and there are 2 exceptions, or there are 3 exceptions. Our 3 exceptions are zinc, cadmium, and silver, but you do not need to memorize these exceptions. So I just want you to think whenever we use anything in this red box, it needs a valence electron when we name it. So look over your notes and make sure that your notes look like my notes. Feel free to pause the video. Now let's practice. So we're going to write the name of the ionic compound formed between Pb4 plus and S2 minus. So the first thing we need to do is identify our metal and our non-metal. Remember, metals, they are cations, and cations are positively charged. So Pb4 plus is our metal. That makes S2 minus our non-metal. And when we look at this, Pb is located in our red box. That means it is multivalent. And S is a non-metal. It is located after the staircase, to the right of the staircase. So to name this, we start with our metal, which is Pb, and we find the name for Pb, which is lead. So it'll be lead, and since it is multivalent, we need to indicate the charge. Well, what's the charge on our element of lead? It is a 4 plus. So let's look back at our Roman numerals, and we're going to be using the Roman numeral 4. That indicates the charge of lead, and then sulfur becomes sulfide. And that's all there is to it. Go ahead and do the other 2 and then get Ms. Lehman to check them.